Hey class, Mr. Houston here. Today we are wrapping up Chapter 4 with Lesson 9, and we're going to talk about performing congruence transformations. So we talked a little bit about transformations earlier in the chapter. Now we're going to show you what it looks like on a coordinate plane. So the first thing we're going to do is just kind of go back and talk about what kind of transformations that we have. So in this first one here, when it flips its shape, it is a reflection. When it moves about a center point like this does, that is a rotation. And when nothing really changes, it just looks like it moves from one spot to the next. This is known as a translation. So there's special coordinate notation that we use for each one of these transformations. The first one we're going to talk about is a translation. And in a translation, even though if we look over here, it looks like this is sliding from here to here. On a coordinate plane, it's going to move either to the left or to the right, and then it's going to move up or down. So we're adjusting the XY coordinates from the original to the new image. So all we do is you will see it written like this. Now, because it says x plus a and y plus b, doesn't mean you can't have subtraction in there. They just mean that if we were going from here to here, that now obviously we're going to be subtracting here and subtracting here. So it just depends on which direction you are moving. Okay, so anytime you see addition or subtraction being done to a coordinate, that is going to be a translation. All right, so let's take a look at that here in example number 2. So I'm telling you that A, B, C, D has these vertices, and I want you to perform the translation, of x plus 5, y minus 2. So I'm gonna do more than I need to, but if I have A and I'm at negative 4, 3, to get to A prime, I'm going to take negative 4 plus 5 and 3 minus 2. So that would net me at 1, 1. I'm going to do the same thing for B. Again, probably going a little overboard in my explanation here, but I just want you to understand how this works. So it'd be negative 2 plus 5 and 4 minus 2, giving us positive 3, positive 2. C started at negative 1, positive 1. When we translate to C prime, negative 1 plus 5, positive 1 minus 2. That would net us out at 4, negative 1. And then D started at negative 3, 1, and translated to D prime by adding 5 to negative 3 and subtracting 1 from 2, giving us 2, positive negative 1. So these were the original figure. If you were to perform this translation, understand that you would add 5 and then subtract 2, and then we would be here for our primes. Just to kind of talk about something real quick, if you remember, in the coordinate plane, if we are going to move to the right, you're going to be adding. If you move to the left, you're going to be subtracting. If you move up, you're going to be adding, and if you move down, you'll be subtracting. So just remember that when you look at these, or if you're actually going to graph them, make sure you understand the different directions you'll move based upon the signs in between the letters and numbers. All right, flip over to the back side. For a reflection, this is where it gets a little interesting, but for a reflection, if we reflect in the x-axis, the y-coordinate is going to become its opposite. So x-axis, y-coordinate becomes the opposite. And then if we are in the y-axis, then the x-coordinate will become its opposite. So just remember that if I'm whatever axis I'm reflecting across, the opposite coordinate is the one that will be changing. All right. So you are drawing a pattern for a wooden sign. Use a reflection in the x-axis to draw the other half of the pattern. I don't want you to draw it. I want you to give me the coordinates of these points right here if we reflect it. Actually, we're going to take off that last one. So we'll call this A, and that's going to be at -1, comma 2. We'll call this B, that's at 1, comma 2. We'll call this C, 1, comma 4. So we are reflecting across the x-axis, which means my y component is what's going to change. So for A prime, or for A, if I'm at -1, comma 2, if I translate that into A prime, my x coordinate stays the same, my y coordinate becomes the opposite. At B, I'm at 1, comma 2. To get to B prime, leave the x coordinate the same, change the y coordinate. And then finally at C, we were at 1, comma 4. Flipping that over the x-axis, not B prime, C prime would be at 1, comma -4. Okay? So again, whatever axis it is, you're then going to flip the opposite coordinate. All right. And then lastly, we're just going to take a look at these two examples here, and they want to know, is this a rotation or is it something else? So they want to know, is it a rotation about the origin? Now when they say a rotation about the origin, that means the origin is the center of it. So if we look here at A, we're looking here, and it's already shown us, but this is going to be a rotation. I wish they would have in this called this A prime and B prime, because it would be a little easier to see that this is rotating about the origin. So again, we're rotating around this point, and you can see that this is going to rotate here, and this is going to rotate here. So one thing I want to point out is that A is at -3, comma 1, and then A prime is at 1, comma 3. So one thing, when we're rotating at 90 degrees, these points are going to flip-flop. So we'll say that if this is A and B, when we go to A prime, it's going to be the opposite, B, the opposite of A. So this was -3 here, but then over here it became +3. This was +1 here, and it just stayed the same and just came over. So that's a 90-degree rotation. So then we'll take a look here at this last example. And if we look here, we'll call this A prime, and we'll call this B prime to make it easier to see. Is there any type of rotation that we could do, whether it's this way or if it's this way? Can we rotate that and make this match up? The answer to that is no. There's nothing we can do to make it rotate and look that way. Rotations will still have the letters kind of in the same order, but there's no way to rotate this right here anyway to go this way or this way to make it look like that. All right, so that's just a little bit more about transformations and how we can do them in the coordinate plane. Big key on making sure we understand what coordinate notation is and what it looks like for a rotation, a reflection, and a translation. So make sure you look at that. If you have any questions, bring them with you to class, and we will see you then.